Rounding off the chapter, quick discussion on power. In everyday kind of language, we tend to mix up the words energy and power quite a lot. But in physics, there's a very distinct separation between what we call energy, which is how much work gets done, and power, which is how quickly the work gets done. The equation of power is the amount of work that gets done over a certain amount of time. So it's a rate at which the work gets done. Unit-wise, of course, is joules per second, which we define to be 1 watt, which is 1 W. Unfortunate kind of thing where W stands for watts here and W stands for work over there, but hopefully you guys are kind of used to that kind of stuff. In any case, this question is quite straightforward use of that particular equation. We're told that you do so much work over so much time, but since we want things in nice joules per second, which is a watt, let's convert this hour into seconds, and we get 208 watts, which is rather high because normally a normal person can consistently output 100 watts pretty much continuously. But at 200 watts, this person is really working hard. So part B flips around the equation, also pretty simple. But in order to find the work, we have to look at the energy briefly. So somehow there's a massive load of brick somewhere here, and a little later, the massive load of brick is up there. We don't quite know what happens in between. There could be a ramp, maybe it's just been lifted, or maybe there's some pulley system, I don't know. Nor do I care. All I need to know is the stack of bricks is not moving to begin with or to end up with. And it started as I define it, at 0 height, and ended up at 1.5 meters. So we have no kinetic energies before and after. We have no initial potential gravitational. There's no springs involved. We don't have to care about that. And the work done here, we're not told a lot about what happens in between. And it's true that there can be some maybe friction involved as you lift up the brick and you have to lift up the person, but those are not considered useful. So the only useful part would be the work done here is equal to mgh2. So then to get the power, we get work over delta t, which is in this case mgh2 delta t. And so if we want delta t, we gotta flip it around. 2,000 kilograms worth of brick being lifted up 1.5 meters, which gets us 141 seconds. And if you divide that by 60, you kind of find out that's about just a little bit under 2.5 minutes. So quick refresher on this concept called power, and hope that you don't mix it up with energy.